This Zoom session is being brought to you by the Fractal Bullseye Horizon.
Here, sorry, I didn't.
All right, here we go. All right, for today, we start off chapter 3. Okay. It starts off by talking about the inverse trigonometric functions, specifically inverse sine, inverse cosine, and inverse tangent. The idea of an inverse function is that it undoes what a function does. So sines, and cosines go from angles to x and y coordinates on a circle. Well, inverse sine and inverse cosine go the opposite way around, from coordinates on a circle to the angle that reaches it. Okay, so start with the arc sine, written like this, and also by a sine inverse of x. I'm not entirely happy with that -1 because it looks like a reciprocal, which it isn't. However, you can, on your calculator, it will be accessed by a inverse here, sine inverse. Maybe you can see that, and a cos inverse and a tan inverse written in the yellow button and yellow text. Okay, so y is arc sine of x if sine of y equals x. Like I say, it's an inverse function. Here's the idea. Consider a circle, unit circle, go down a distance x along the y-axis. Here's an angle y which reaches it. The angle y is to be taken from -90 degrees to +90 degrees. That is between minus pi halves to plus pi halves. The graph of the arc sine is like this. It's basically a bit of the sine graph marching up and down the y-axis, only this small branch of it. Arc cosine, written this way, arc cos and cos inverse. Y is arc cos x if and only if cosine y equals x. So here we have a unit circle, and we go back and forth in x distance x along the x-axis, and we want to find out what angle y reaches it on the upper half of the circle. The upper half is between y between 0 radians and pi radians here. So here's the graph of it. Again, this looks like a cosine graph marching up the y-axis, but we just chop off this piece of it for the graph of arc cosine. Arc tangent, y is arc tan x equals tan inverse x if tangent y equals x. Here we have the unit circle, and tangent is this distance x over 1. I want to find which angle y reaches that. And like the arc sine, the y is to be between minus pi halves radians to pi halves radians. So what we do is we take a fraction of the tangent graph marching up the y-axis, and we take this branch of it, and here's what it looks like. All right, so tangent of arc tan x equals x for all x, and arctan of tan x equals x if x is between pi halves and minus pi halves radians. Otherwise, arctangent isn't actually defined. Oh, okay. So arc sine 1, arc sine -1, what's that? Well, want to find the point on the unit circle with y value -1. It's here at the very bottom of the circle, and you reach that by going this angle, minus 90 degrees or minus pi halves radians. So arc sine -1 is minus pi halves. Arc sine √2/2 is what? Well, here we need an angle whose sine is √2/2. So we do this isosceles right triangle with far side, near side √2 and hypotenuse 2. This is a equilateral right triangle with an angle here of 45 degrees, or in other words, pi over 4. So arc sine √2/2 is 45 degrees, aka pi over 4. Now, okay, here we have arc tangent of -0.4. Well, all right, there's no obvious answer, no exact answer that I can think of, but fortunately your calculator will be able to do that, and it'll give you a -0.380506, that's ... radians. And yeah, here I'm assuming radians. Unless we specify degrees, all these answers are to be in radians. Okay. Arctan √3 is what? Okay, well, opposite, here we draw a triangle with the opposite side √3, this side 1, and therefore by Pythagoras, the far side is 2. This is a part of a 30, 60, 90 triangle. This is the 60 degrees, which is pi over 3 radians. So that's arctan root 3, pi over 3 radians. And here we have arcsine of negative 0.1, negative 0.12. And again, you run to the calculator and it'll give you negative 0.120289 radians. Different number if it is put in degrees. Okay, for this one, they ask to invert a function. And all right, it'll be an inverse because really arcsine is really one of many inverses of sine. But we'll go for that anyhow. So to invert this 5 sine x over 2, we set y equals f inverse of x. So f of y equals x. And so using this definition, it'd be 5 sine y plus 2 equals x. And then we go about solving. First, we subtract 2 from both sides. 5 sine y equals x minus 2. We divide both sides by 5. So sine y is x minus 2 over 5. And then we take an arcsine. Y is arcsine x minus 2 over 5, although in truth, there are many solutions to this equation. So this will do as an one of many inverses of this function. Arcsine of x minus 2 over 5. Solve for arcsine x equals pi. All right. Okay, here we divide both sides by 4. Arcsine x equals pi over 4. Here we can take sine of both sides and unambiguously get x on the left side. On the right side is sine of pi over 4, which that's sine of 45 degrees. And again, by usual right triangle, standard right triangle, that's root 2 over 2. Here we have 4 arc cosine x minus 2 pi equals 2 arc cosine x. This is a matter for some algebra. First, we transpose the 2 arc cosine x to the left, the 2 pi to the right. That by subtracting 2 arc cosine from both sides and adding 2 pi to both sides. So 4 arc cos x minus 2 arc cos x equals 2 pi. Combine these two terms on the left. That's 2 arc cosine x equals 2 pi. Divide by 2. Arc cosine x equals pi. Take cosine of both sides. That can be done unambiguously. Get x equals cosine pi, and pi gets you from, you can see, it moves you halfway around the circle. Point -1 by 0. -1 is the cosine value. So x equals -1. Okay, looks good.